twist it around, I can look down through this end if you're doing something in design. Have I ever used this to help a company maybe do something? And you'd be like, he's a math teacher. I actually have. I've used it just to design, because they have stuff and I go, I can make that with point blot and kind of get an idea of what you got there. Give you a nice sketch. Well, they're not all perfectly, these were circular cylinders, right? Well then what the heck is this? This is my note.
Coefficient?
That's still a cylinder, it's just not a circular cylinder. Do you know what that does to a circle?
Sphere?
Not a sphere. Sphere's coming up though. I heard ellipse. When a circle, when the coefficients of the x and y are always the same, what if one's off a little bit? You know, one's a 1, but the other one's a what? 9. It makes it more like an oval in two-dimensional space. They call it an ellipse. So this is still a cylinder, it's just not a perfect circular cylinder. It's more like an elliptical cylinder. Alright? What I mean, it's got what? Rather than being a total circle and going up right, it's more like what?
Like a donut.
Yeah, and then it goes like this forever, right? Like someone got all mad and they took the trash can and what? And they squished it. And that's what came out of it, true? Well, if I wanted to make a sketch of this, you sure can. I use the intercepts. That's what I do. So I'm curious, everyone. What if, in this equation, what if x was 0? What would z have to be? Remember, I'm just going to, everyone, since I just want to get 1 point going on, I'm going to let y equals 0. Is that cool? What would z have to be?
3.
And I'll put plus or minus 3. Do you agree?
Uh-huh.
Okay, so that would mean, okay, it'd have to be stretched out. Whoops, I'm going the wrong way. 3 on the what? The z-axis, then I can go down what? 3. There you go. 3 up that way, 3 that way. I need another intercept. Well, in this time, let the z and the y be 0.
Plus minus 1.
See how quick you are? Wouldn't x have to be plus or minus 1? Don't see that? So which way was it more elongated? Yeah, look at this. See, it's like you said, the squished. It's all squished. It's an ellipse here. But now it turns into a what? An elliptical what? So when you get one off, you're like, yeah, it's just elliptical.
It looks, on the side, it looks kind of like a football.
That's right. That goes on forever.
Yep.
I know, sometimes I'm trying to think of this thing. It's like, okay, make it more circular with your folder. Okay, that's more like the circular cylinder, right? Right? But now with that thing, it's more what? Right?
Yeah.
Right? I mean, I'm trying to make it more elliptical. It's like taking that and squishing it. That's what's going on. Still a cylinder. Well, are they all like circulars or ellipses? Nah. Anybody ever see that half pipe at the Olympics? So let me talk about this. Okay. And let me say, I want you to sketch this surface, but let me be careful. If I just said this, you might just draw it in the XY plane, right? I need you to sketch this in
3D.
three-dimensional space, in 3D space. I mean, three-dimensional space, I need you to sketch this. Which letter's missing?
Z.
It means Z can be anything. So let's see what this looks like. It's much clearer. Like, have you ever seen that half pipe at the Olympics? Look, there's the y-axis, there's the x-axis. Wouldn't a parabola run for y equals x squared just kind of come out like this? Like that?
Uh-huh.
You know, there's the y-axis, there's the x-axis. It'd be sitting down there in the xy plane for y equals x squared, right? But we said z could be what?
Anything.
So I need you to ride up a line. Just go stay parallel to that z-axis. I can stay more straight. Let me do it again. Ride it up. And would you duplicate that trace right there? Just go up here and just kind of go. I hit the axis. I'll come back. If you want to shade it in, you can. Does everyone see it's like a half pipe from upside down? You want to give it some color. Does everyone see it?
And in that case, it's the lowest point of the z-axis.
And this could go on forever, though. Do you agree?
Yeah.
This thing would go on forever. That's it. And you go, what is this called? It's a cylinder. Well, what's the adjective? Parabolic. So it's a parabolic cylinder. But have you ever seen those in the Olympics? The Winter Olympics? I don't, unless, do they have skateboarding in the Summer Olympics? I don't know. I mean, I remember my local towns, someone on one of the streets built one of these. Like right in their front yard. Like they seriously, it was out there. And it was just sitting there and all these, they'd go out there every day with their skateboard.
It's like a
Just
magnet inside a motor.
Yep. And would just like to, I also like to have this, I wish something like this could form in front of my house when there's high wind days. Actually, my backyard, because the wind comes through my backyard. I would love that. It would just take all the wind in one. Save me a ton on my electrical bill. Just like I'd press a button and what would come up? Just come out of the grass. I'm still waiting for someone to design that for me. My neighbors will get mad. It's going to push all the wind towards them, right? Cool. All right, so that's a parabolic cylinder. So we got cylinders, but hey, one more. How about Z equals y squared plus 2. Oh wait, let me do one more thing. Negative. Z equals negative y squared plus 2. How many letters?
2.
2 letters. 3-dimensional space, right? But negative, what did it do to the parabola? Flipped it. What's the plus 2 do? Moved it up 2 notches. And x is missing, so x is going to be anything, right? Well, here's the y-axis, here's the z-axis, right? So I'm thinking, what happened? Well, here's z equals y, right? It's almost like y equals x squared. There's the z-axis, y-axis. You can think like, remember y equal to x squared? Now I have what? Z equals y squared. Well, there's the zy plane. Went up 2 and it went. It flipped what? It flipped over. Do you agree?
Yes.
There's a nice trait. Everyone see how I went up 2 notches, inverted it? But what's missing?
Yes.
X. So I can run parallel lines to the what? The x-axis, and then do another trace like this. So right off here, just run parallel to the x-axis. These are fun to make. You go run and keep running. Now would you repeat this trace? What would it do? It'll just what? Go up, then it'll what? Come down. Let me get that to connect there. Sometimes you gotta extend it. Just stay parallel to that x-axis. It's just another parabolic cylinder, right? Cool. Hey, if you want to shade it in, you can. Now you've probably seen things like this before, right? Like you walked under things like this. Some type of design. I mean, you can download WinBot. It's free software to do this stuff. All right, what's next? The last stuff we're doing are quadric surfaces. These were called what? How many letters did cylinders have?
2.
Last thing, quadric surfaces. And we actually have enough time to do this. Quadric surfaces. How many letters? 3 variables. They will always have 3 variables. What did you say? They will always have 3 letters. That's the way you know it's not a cylinder. So can we all start with the most popular of this guy? X squared plus y squared plus z squared equals 4. That's the one we saw on the first day of class. Except I put an H, K, and L with it, but we're just talking about a simple one. You know what that is? That's the sphere. We saw last class. That's a sphere. Where's its center?
0.
At the origin. At the origin, what's the radius?
2.
2? And when you just want, you can draw a picture of it. Just make like a basketball here. You can swing it around. Doesn't have to be too big. But you know the radius is equal to what? But you know that's a what? Sphere. So right off that problem, we got to go to something that's very close to this, but it's not a perfect sphere. I mean, basketball, it's a sphere, right? A football, is that a sphere? No. So what would happen if you had like x squared plus 4y squared plus 9c squared, and let's just say it equaled 1. You know? Let's just say it equaled 1. Well, that's not a sphere. This is an ellipsoid. We gotta put some other words down to help us understand this. All I did with that basketball that was perfectly nice and neat was squish it. And it turned into a what? A blimp? Think of a blimp. That's an ellipsoid. A football, is that an ellipsoid? Absolutely.
So if you add like 3 coefficient to a sphere, it becomes an ellipsoid.
That's right.
Okay.
You got it. If these were all the same, it turns into a what? A sphere.
Sphere.
Now, when this is going to be more elongated around one axis, do you all agree?
Mhm.
Do you want to figure out how to do this? I always use the intercepts. So what if y and 0 were 0? What would x have to be?
Plus minus 1.
Okay. Just to see which way it's more squished. What if x and y were zeros?
1/3.
11 plus or minus a third. And what if these are zeros?
Plus and minus 1/2.
There you go. So which way is it more elongated? More along the x-axis. X-axis, I'll go 1 away, 1 away. The y-axis, it's what? It's going up a half. Right? Whoops, I just did the z. And it's going 1/2 on the y-axis. But how far is it going up on the z-axis? Just a third. So I'm going to go like a third. And you can just go connect all this stuff like this, like, and then just go, and you're trying to form that what? That blimp, that ellipsoid. You want to make more circles in there, that's what you got. All right. So the next couple, can you just swing that door closed? All right. Hey, almost done. These next two, we've got two things that look very close to each other. So I'm putting them right next to each other. Let's pair these up. How many variables?
3.
Quadric surface. You go, well, are these spheres? No, I don't see the equals 4 thing, right? I don't see the equals 1 or the equals 9, so these are not spheres. I'm going to start with this one. Is this a cylinder? No, because the cylinder only has how many letters?
2.
2 letters. So, to help us understand this, I'm going to hide this. Now I want you to think about that in algebra class. What was that? So this should act like a parabola. Does everyone find this? This is the way you'll never mess it up and recognize this. You know this must act like a parabola. That's why it's going to be a paraboloid. Now, which axis is the paraboloid going to be centered on? The letter that's isolated. Okay? So what I need you to do is just, form up from that z-axis. But now you got to form a circle somewhere because it's going to just keep opening up and opening up. So would you form like some circle somewhere? It's open-ended, it'll just keep going forever. It's called an open surface. It'll never stop what? Opening up. Does that make sense? But that's good enough. It's called a paraboloid. Have you ever seen a windsock? Paraboloid. Paraboloid. Alright, now, come over here, everyone knows the z-axis. By the way, that's a circular paraboloid. What if this had a 4 there and that was a 1? Elliptical paraboloid, that was awesome. That's what it would be. It'd still be a paraboloid, it would just be what? Elliptical. Well, I'm over here. This looks like it's circular, but I'm not making sense of it. I know it's not a paraboloid, so I'm going to hide this, and I'm thinking of algebra. Well, if I square root both sides, you know what I get? I get plus or minus an x. So I'm thinking in algebra, everyone, if z equals plus or minus an x, that would be like this. Now I got to think of that if it goes circular in three-dimensional space. It starts with a C, and it turns into a what? A cone. Does that help? That's how I got to think. I'm like, that in two-dimensional space would do that, right? But I gotta think this is gonna be circular forever in three-dimensional space. What's it gonna turn into? Cones. Like a double cone. It's gonna be a double cone. So different from a paraboid, which kind of opens up like this first. This is just gonna what? And where's it centered? Which axis?
Z.
Whichever letter is right there. I just thought I'd push one. Now everyone, what if this was, hey, I can go off to the side here. What if this was y squared equals x squared plus z squared? Where's the double cone centered?
Y.
So you would just be making a cone on, you'd be like, right? So it comes down like that. And it's always circular unless they put a 4 and a 1 there.
And if it was like the quotient like y minus 2 squared equals x squared plus z squared?
Geez, you won't even see that. I love that. I love how you're thinking more advanced. You go, we always just get this. Now, I want to point something out too. This is usually used for design, everyone. And you usually don't have a double, you just have what? Let me see, it's like a tank and they're pouring what? Oil in here or something. So a lot of times they'll make, right up here they'll go, let z be greater than or equal to 0. And what does that mean?
It's only the top.
It's only the top. The top cone. So I just want to point that out. That's really what you usually have, and it's usually for, there are conical reservoirs and things like that. Cool. All right. And the next two, we'll put them together. So wrap it up. What if it looks like the sphere? One of them's a minus. I'll put one over here too. Now, don't these both look like spheres? Don't they both look like spheres? Cool. But this has how many minuses?
1.
Looks like the sphere, but has one.